So, welcome students. This is an introductory lecture in physics, and the topic of today's video would be waves, which is a rather interesting concept in physics. So, let's just dive right into waves. So, what is wave? Wave is basically a disturbance in medium, which is caused to transfer the energy. So, wave is what? Wave is disturbance in a medium. So wave disturbance, or we can say that any motion in particles of medium from its mean position, oscillations. So in waves, the thing that is traveling is actually energy. No mass or no particle is translated from space, its original position. So that is the principle of waves, that it is a form of energy transfer. So with that, we have concluded the definition of wave. What it is? It is a form of energy transfer which is caused by disturbance in any medium or disturbance in the particles of any medium. Alright, so now let's just classify waves. Waves can be classified into three major categories, which would be: first is mechanical waves. Example of mechanical waves would be sound and ripples in the pond or lake or water. So how we define mechanical waves? Mechanical waves requires a medium and requires the collision of particles of medium to travel the energy. So that is mechanical waves. Second would be electromagnetic waves. So electromagnetic waves, what are those? Those waves doesn't require any medium. Those are disturbances in electric and magnetic field. So these are electromagnetic waves. And the third one would be matter waves. The matter waves are a quantum mechanical phenomena which states that every matter has its wavelength or can behave like a wave, which is not to focus right now. Our main focus would be electromagnetic waves and mechanical waves. And for the basic understanding, let's just focus on mechanical waves. Now, mechanical waves are further classified into two categories. That would be, first one, longitudinal wave, and the second one would be transverse waves. So, how can we categorize longitudinal wave and transverse waves? Longitudinal waves are the disturbances in the medium which is parallel to the wave propagation. By wave propagation, we mean what? By wave propagation, let's just say wave is traveling in this direction. Particles are moving up and down with its mean position. So this represents transverse wave, meaning it is perpendicular to the particle oscillate perpendicular to the motion of waves. And in longitudinal case, what happens that particles move along or parallel with the wave propagation. Wave is traveling this way and particles are moving to and fro parallelly with the motion of waves. So this is how a wave gets its energy transferred, or energy is transferred in the form of waves. How? In two ways, longitudinal and transverse mode. Longitudinal wave would be particles oscillating parallelly with respect to the motion of energy, and transverse would be particles traveling perpendicularly with the wave propagation. So now, since we are discussing waves, and we have defined waves. What are waves? Just basically disturbance in any medium. Now let's just categorize it more. Let's create some parameters to define waves. Just like we have names, waves have some properties to distinguish between them. So the one property of wave would be its amplitude. Amplitude. What an amplitude is? Let's say a particle is oscillating up and down from its mean position. So this is its mean position, and it went up high and again down with respect to time. So the motion would look just like this. What just happened? The particle didn't translate it from its mean position. It is just oscillating up and down its mean position. So with time, if you look at the motion, this is the motion time graph of this particle. It would look something like that. Now, amplitude is something that amplitude is a distance that is traveled by this particle from its mean position up to the highest point. This is an amplitude, and this is also an amplitude. So it would be same to and fro from the mean position because it's oscillating. So amplitude, we have defined amplitude. Now another parameter of waves is wavelength. What's the wavelength is? So wavelength is defined as the distance between crests or the peaks or valleys, meaning this distance right here is wavelength, and it is represented by a Greek letter called lambda. So this right here is wavelength. This is the wavelength. Then there would be the same. So distance between two crests or two valleys. This is called wavelength. So we have defined one parameter which is amplitude, another parameter which is wavelength. Now there is another parameter we call frequency. Frequency of a wave. Frequency is what? Frequency, how much of wave is traveling per area in unit time. Meaning what? Meaning if let's say this is just one complete cycle, because the particle translated from its mean position up, then again down, and again came to its mean position. So this is one cycle, and this one cycle is called one wave. So this one wave, how much of this wave is passing through a point or a plane in unit time? That is called frequency. It is noted by F. Alright, so this is frequency. So now we have defined few terms or few what we say quantities for our wave. Now let's just move forward. By the way, the waves which transfer energy but doesn't translate its particles or medium's particles, it's called progressive waves. So all the mechanical waves are progressive waves. An example would be the ripples in the pond. Another example would be a rope tied to a wall and grabbed by one hand, and when it is shaken down, it carries a peak, it carries a bulge, and this bulge travels along. So after some time this bulge would be here, so and after some time this would be here. So that is how a wave in a rope works. And this point of contact would feel a force. That force is the energy transferred by the rope or the particles of rope. But in actual, the rope didn't have traveled. What is traveled is energy. So this is how a wave works. Now, since we have defined some parameters of wave, now let's dive into more deeply. Now, waves are nothing but traveling energies. So energies should be having a rate of traveling, or we have to say that it should be having a speed of energy transfer. How? Let's just say that we have a wave traveling, and this wave is traveling with a frequency, something which would have a frequency and wavelength, and it would have a time period. Now, what the time period is? We didn't define that, which is one. Time period is time taken in one complete cycle. So this time period is just time taken by the wave to complete one cycle. So this is the time period. Now, in one complete cycle, and all right. So we were talking about the speed of the wave. What would the speed of the wave would be? So in general physics, we say that speed is something that distance over time, which means the distance traveled by something in a unit time. So distance over, let's say, unit time. So what now speed is distance over time. Now we are talking about which speed specifically? The speed of this crest traveling, because this is the highest point. Actually, it will travel. After some time, it will be here. And after some time, it will be moving forward. So this is called wavefront. The highest point or the most forward part of the wave is called wavefront. So wavefront is traveling. It is changing its distance from initial position now. Getting my point? Actual particles are not changing their position. They are there. They belong. They are just oscillating. But the energy is going around in the form of wavefront. So that energy moving, or that wavefront, has some certain speed, which would be distance traveled by it per unit time. So let's just call the speed of the wave is v, and it would be distance of wavefront over unit time. So wave has speed actually. Yes, indeed it has. Now, since we have defined the wave's velocity or speed, we can define wavelength in terms of wavefront also. How? For a wave which has time period t. Now, time period is actually unit time for this wave, meaning for one complete cycle, the wave would take time t, and in that time, the wavefront would travel lambda distance. Getting my point? So lambda distance is distance traveled by wavefront in time t, or which is unit time for this wave. So now, again, going with the definition of our velocity or speed of the wave, distance traveled by wavefront in unit time. So unit time would be t, and distance would be lambda. So we have another definition of speed of the wave, which is lambda, which is our wavelength over time period. V is lambda over time period. Now, this time period, we can change it further. We know that wave have frequency, and frequency is defined as 1 over time period, which is inverse of time period actually, and frequency has unit of hertz. Hz it is, or it has unit of per second. So we can use this definition of frequency and put 1 over t equals to f in this equation. So let's make it more clear. So now the speed of the wave becomes lambda times frequency. Light speed has unit as meters per second. So this is now the new speed in terms of frequency and wavelength. So this is something, and let's define more parameters of the waves. Wave have something we call uh, crest, and though we call it wavelengths. Now let's just take case of two waves. There are two waves traveling, but there is a catch. What's the catch? So one wave started some point, but another wave, it is lagging behind. It has started a little lately. So what this have created? This has created a distance between the crest, or difference between the valleys or those of these two waves. This distance is similar all along, but has something. So this distance we call a phase difference. Phase difference. So whenever two waves with same frequency, keep in mind the frequency of wave should be similar. So whenever two waves going along with each other has the same frequency, but they are misaligned with respect of time. So the time period for both the waves from let's say here to here, this would be here to here, is t. For time period of first wave and time period of second wave, they both are equal. The frequency of first wave is equal to frequency of second wave, but there is difference in their crest, their position. So this is called phase difference. So phase difference is something that we can calculate. So phase difference, PHAC difference, is how we calculate it. If this wave have time period t, both the wave have time period t, and one has the other wave, the second wave, started sometime t, after some time t. Say t is a time period, and the difference between both the waves is t. So the phase difference would be difference between time over time period multiplied by, if we are calculating in radians, it will be 2 pi. So this is the phase difference. Or if we are calculating in degrees, so it would be t over time period times 360 degrees. So phase difference actually tells us that how much difference in time both waves are lagging. If there is some difference between both the waves, how much it is.